Hello friends. In the previous part of redox reactions, we have discussed about the concept of redox reactions. What is the meaning of redox reaction? How can we identify oxidation and reduction? Now after that, the next thing which we have to discuss, that is oxidation number. Okay. First of all, before starting the discussion about the oxidation number, we have to know that what is the mean of oxidation number. Oxidation number is the actual charge present on an atom in a given species. Given species may be like ions, molecules, and atoms itself. That is known as oxidation number of an atom. Oxidation number is the actual charge present on an atom in a given species. It means ions, molecules, and atoms. Means when an ion is there, suppose that is Cl minus. So what is the actual charge present on Cl in this ion? That is known as oxidation number. In the same way, suppose that is Na plus. Again the same thing is there. The actual charge present on this sodium atom, sodium ion, that is known as oxidation number. The same way, H2O, what is the actual charge present on oxygen or hydrogen, that is known as oxidation number. So this is the meaning of oxidation number. Now, to assign the oxidation number, we have to follow some rules. Rules for oxidation number. The first rule is that when an atom present in a free state and in a molecules of element, the oxidation number of that atom is always 0. Meaning is that, suppose we discuss about an A. So whenever this sodium atom combine to other atoms, it is known as free state, and in the free state of each and every atom the oxidation number is 0. In the same way, suppose we have hydrogen. This is the molecule of an hydrogen gas. So hydrogen combined itself only with hydrogen. So in this case also, the oxidation number of hydrogen or that atom is always 0. Second, in a monoatomic ion, the oxidation number of an atom is always equals to charge present on given ion. It means Ca2 plus and S2 minus. Monoatomic. Monoatomic means when an ion only contain one atom. Calcium, one atom. Sulfur, one atom. So in such cases, the oxidation number of calcium here will be plus 2 and the oxidation number of sulfur here will be minus 2. In the same way, we can find out the oxidation number of any ions. Third, the oxidation number of hydrogen is generally +1 in a molecule of compound, just like this. HCl, oxidation number of hydrogen will be here +1. NH3, oxidation number of hydrogen will be +1. But in the metal hydride, the oxidation number of hydrogen is always -1, because in the metal hydride the hydrogen is more electronegative as compared to metal, just like this. NH, we know that metals have low electron negativity value. Hydrogen is a non-metal, so it has more electronegativity value as compared to metals. So in all the metal hydrides the oxidation number of hydrogen is always -1. This is exceptional case. Fourth, the oxidation number of oxygen is generally -2. It means in all the oxides oxidation number of oxygen is -2, like this. Na2O oxidation number is -2. CO2 oxidation number is -2. This is the meaning. But in peroxide oxidation number of oxygen is -1. What is the meaning of peroxide? In the peroxide oxygen connected with the another oxygen atom through single bond, just like this. H2O2, H2O2. So if you want to calculate the oxidation number of oxygen here, hydrogen we have already discussed, that is +1, because there are two atoms of hydrogen, so we have mentioned here 2 into 1 plus 2 into X is equals to 0. X is the oxidation number of single oxygen atom. There are two atoms, so we have mentioned here 2X. So when we adjust it, 2 plus 2X is equal to 0. Again 2X is equals to -2, so X is equals to -2 divided by 2 is equals to -1. In the same way, oxidation number of oxygen in superoxide. Okay. In the superoxide, the formula of oxygen is MO2, like this. Okay, like KO2 is always -1 by 2, -1 by 2. In this potassium, we will discuss the next part. Oxidation state of potassium is +1, plus 2X is equals to 0. So it is 1 plus 2X is equals to 0. So it is equals to 2X is equals to -1. So X is equals to -1 by 2. So these are the some exceptional cases regarding the oxidation number of oxygen. In normal oxides, -2, peroxide -1, superoxide -half. And one more twist is there. Okay? When oxygen is attached to highly electronegative elements as compared to it means fluorine. In the entire periodic table, the electron negativity of fluorine is 4 and the electron negativity of oxygen, that is 3.5. So this is the first element which has the highest electron negativity, and the oxygen is the second element which has the second position in the electron negativity. So when oxygen connected to the fluorine, just like this, OF2 or O2F2, in such type of compounds, the oxidation number or oxidation state of oxygen is always in plus, just like this. OF2, oxygen X plus 2 minus 1 is equals to 0. Fluorine, we'll discuss, the oxidation state of halogen is always minus 1. So here X minus 2 is equals to 0. So X is equals to plus 2. First. Second, O2F2, again it is 2x plus 2 minus 1 is equals to 0. Is it 2x minus 2 is equals to 0. So 2x is equals to 2. X is equals to 2 by 2 is equals to 1. Is a plus 1. So these are the example cases regarding the oxidation number of oxygen. Now fifth, the oxidation number of group first element is always plus 1 and group second element is always plus 2, meaning is that sodium, in all the compounds of sodium, its oxidation state will be here plus 1 in compounds, not in free state. Okay, the same way calcium, in all the compounds of calcium, the oxidation state of calcium will be here plus 2. So it is fixed for group first and group second. So these are the some basic rules to find out the oxidation number. Okay, first in free state, second for monoatomic ion, third for hydrogen, fourth for oxygen, and fifth for group first and second elements. Then in the remaining cases, to determine the oxidation number or oxidation state, we have to use these rules to calculate the oxidation number. And second thing is that when we are going to determine the oxidation number, we should involve structure of the molecule also. The structure is also plays a very important role to determine the oxidation number of any atom of an element. Okay, how can we determine the oxidation number of various atoms in the given problems? We will discuss in the next part of this chapter. Thank you so much.